Thank you very much. Thank you, guys. Spasibo, right? All right, let's get started then. Yeah, as I was saying, it's very interesting to be here. Even though this sounds like an Android-related talk, it's not fully Android. I will highlight just some Android pieces, But the main idea here is to talk about RxJava and how we use it in our company, in our solutions. I was talking with a few people here. Yuri, I see you're there. You're not an Android developer. But the idea is to walk you through the different components of RxJava and how we can apply them on Android development in Java in general. So a couple of questions first. How many of you have played around RxJava here? Just a little bit, or you have used it in live projects, just by yourself? Yeah, you have been using it. Cool. So good to know then. So, but first, well, here is my blog. I usually try to write some stuff Android related, Java related, lately RxJava related. Just to give you a little bit of me, what I've been doing lately. So I'm the same as you. I'm a curious learner. I'm a geek. I'm pretty sure that most of the people here are. Software engineer, I work at SoundCloud. SoundCloud is a music platform. We face a lot of challenges related about it. So you might or might not know it. But so let's get started. I usually like to start by saying what reactive is, because many people don't know what reactive is, like why the name reactive programming, why RxJava. So reactive is something that is responsive to a stimulus, all right, we know that. This is a dictionary term, so it's related to or marked by reaction or reactance. So don't take this into account yet, but just keep the picture in mind, because by the end of the talk you should know what is this and what's happening here. Well, it's not, like pretty hard, right, to figure it out, but yeah. So what is RxJava in general? RxJava is a JVM implementation of what is called reactive extensions. These reactive extensions were built by Microsoft, surprisingly. Sorry, Microsoft. And it was created by Eric Meyer originally. So there were some ports of those reactive extensions since they were pretty useful, and we will see here why. And there's like a few implementations of that. Like, for example, there's Rx Kotlin, there is Rx Scala, and of course we are going to talk RxJava here. So RxJava stands for a library JVM implementation. It's a library for composing asynchronous and event-based programs by using observable sequences. This might sound a little bit weird in the beginning, but yeah, let's continue. So I usually like to put this kind of question because I want you to have an idea why it's good to go reactive and what are the problems that reactive programming try to solve in a better way. And there are no silver bullets, right? That doesn't exist. So, but I think that we are facing some certain problems, especially when it comes to concurrency. On Android, to give you some insight, we have to always step out of the main UI thread, as soon as we can. So we deal a lot with concurrency. In our case, at SoundCloud, for example, when we are playing songs on the Android client, we need to make sure that our app is responsive. So, when you have the player open, we are just like launching 5 threads at the same time to get the first bunch of MP3 files. So when the users move to a next song, we already have that. So we have a lot of concurrency problems, and especially with resources, the limitations that we have on mobile platforms. So to deal with this, we have Java futures. Unfortunately, we are stuck to Java 7 on Android for all of you that are not Android developers. I think there's going to be a talk related to Jack and Jill, which is a new compiler which is going to bring up some Java 8 features, but still it's not very mature. We have alternatives like Kotlin. I know people here who have been dealing with Kotlin, and you know, the previous talk was really interesting too. So, but on our side and our current situation is that we have to deal with that with Java 7. So we have Java futures. So don't get confused with the futures of Java 8, which are a bit different. But here they block, and then I'm going to show you some sample code here. And then we can deal with callbacks, which is a good way to get a response when we are doing something in a separate thread, for example. So this is an example of the use of a Java future. So basically just you like highlight what's going on here. We have a full executor. We have two futures, two tasks executed, and we submitted them to the pool of threads, and then we just print the result, right? So here, the main point is that on this get, this is going to block. So this is not going to print until both tasks are done. So this is a problem because we cannot parallelize correctly here. And this is another one, which, you know, it's adding more and more complexity. So I'm not going to go, you know, and walk you through each line of code here, but I just wanted to point out, you know, what's going on, and that these kind of things affect the readability of our code, and it makes it messy. So, and more, even more. I mean, this was part of like our original code base when we started like dealing with synchronization and multi-threading on Android. So, and I actually simplified it a lot here. And so, again, so we have to deal with this. We have a lot of problems with code readability. There's no simple solution when it comes to multi-threading and synchronization. So we can rely on callbacks as well, right? So here, this is a nested callbacks API call. So as you can see here, I have a callback here, and then inside it, I'm executing another task, waiting for the response, and then printing something. This might be okay in certain cases, but I mean, the more we add levels of synchronization, the more complex our code becomes. So this is not helpful, and of course it makes our code unreadable and complex. So let me introduce what I call the RxJava guys. So from now on, we're going to talk about RxJava, and these are the main components or the things, the main concepts that you need to know in order to understand and to dive deeper into RxJava. We have observers, we have subscribers, subscriptions, schedulers, and operators. Are you guys familiar with some of these concepts? Probably the people who have played around RxJava. So let's start with observables. I think this is the main concept of RxJava, and something that I wanted to point out here is the difference between reactive programming and imperative programming. When we are doing imperative programming, we are basically doing a pooling mode. Like, for example, we have a producer that produces some certain data. We have a consumer that consumes that data. In imperative programming, what we are doing is just to pool the data, right? So on the other hand, on reactive programming, we have our producer just executing any task. And then that's going to emit something, and we are just waiting with our consumer, and that consumer is going to consume that data. So it's more a push model. So that simplifies a lot multi-threading. So to give you like a tiny concept of what an observable is, it's represent an object that sends some notifications to a subscriber or observer, whatever it is. So another quick question, are you familiar with the concept of monads? Do you know what a monad is? Yeah, you do? Do you know how to explain what a monad is? Because usually there's tons of articles, when people like put in a lot of effort on trying to explain what a monad is. I would try to explain what a monad is, and this is like a fundamental concept in reactive programming and functional programming. So basically, a monad, it's like let's think like a bubble which encapsulates a computation. So that's, and then with that computation, with that monad, you can compose and transform the data emitted by that monad. All right. This might sound a little bit hard to understand, but that's what an observable is. So we have a certain task that's going to be performed by the observable. The observable will start emitting items to our subscriber. And we can do anything with that, with those items. We can transform them, we can compose them, and we will see that RxJava brings a lot of built-in operators to deal with this kind of data. We will see examples too. So I talked about observables and reactive programming and a producer, a consumer. And so an observable, in order to start emitting items, needs someone that listens to those emitted items. So this is not more than an observer pattern from the Gang of Four book. I mean, we all know what an observer pattern is. But it adds two cool things. The first one, the observable, when performing a task, let's say like an API call, we encapsulate it inside an observable. Then we subscribe to that observable, and the observable is going to emit a signal when that API call is done. So that's another thing. We will see what a subscriber looks like. So you will see that we need to override a certain bunch of methods. But keep this in mind. The observable is an observer pattern which has two semantics to it. So the first one, emit a signal when it's complete, and emits a signal if there was an error. So that's a cool thing about observables. We will see that in more details in a quick sample. I wanted to represent a little bit what an observable is like. And so let's say one thing. We have an observable here, a computation that, I don't know, goes to an API and start emitting weather conditions. Just like there's someone listening to those weather conditions, to that data. And we have then another observable that emits the mood stream, the mood data, like how you feel today. So the cool thing about these two observables, so this is a timeline, so the observable is going to be emitting these items for a certain period of time. Then we have the mood stream doing the same thing. And we can compose them together. We can say, all right, let's map this. Let's put it together. And you will see how easy it is doing that. And so as a result, we have another observable which contains both data coming from each of the previous observables. So let's think of an observable like a unit of work that is performing some kind of task. And then we can do anything with that. We can compose them. And here we were going to have some kind of client or observer that don't care about what's going on in the middle. So we're going to have like a pipeline of observable, of units of work that is going to be performing certain tasks. And we can do anything. We can filter them. We can compose them, and so forth. And our client we're not going to touch our client. Our client knows how to interpret those results, and just that. So that's the cool thing that makes our code easier to maintain, for example, because we are not dealing with touching our code, everything that our client, everything that there is a big change, unless we change the contract, of course. Something to keep in mind when we talk about RxJava, and of course Java 8 has this stream API. So in RxJava everything is a stream. All the items we are emitting is a stream. It's a stream of items. Subscribers. So what is subscribers? Again, the subscriber is the guy who's going to receive all those push notifications coming from the observable, right? So no more to say here. This is like it's like the formal definition of a subscriber, but keep that in mind, it's pretty simple. Again, it's not an observer pattern. There is a cool thing here when we have observables doing a certain, I like to repeat a lot, you know, the concepts. So you guys, you know, at least when you leave this room, you're going to hate me for repeating this, but at least you will have this in mind too. So there's two types of observables, and the first one is that the cool thing is that when we create an observable that is going to perform this task, it's not going to start emitting any items until it has someone which listens to it. So that is called a cold observable. Then we have hot observables that are constantly emitting, and whoever subscribes to them gets all the data. But honestly, from my experience, I haven't seen that on Android yet. And if someone here has played around some kind of backend side or with RxJava, maybe know another use case, but I don't think they are extensively used, hot observables. Well, this is what I pointed out before. This is what a subscriber looks like. It's basically when we are using RxJava, we need to extend a subscriber, and we subscribe this class to our observable, and we have to override these three methods. The onComplete, of course, when we get our job done. We have an error. If there's something happening in the middle, we know how to react to it, and we can handle our error in the way we want. And on next. This on next is actually where we are receiving our data. There's something very important here. So when we are linking an observable with an observer or a subscriber, it's the same thing. You can use the concept interchangeably. We create a subscription. Why this is important? At least from a mobile perspective and from an Android perspective, you know that the system can kill your screens at any point in time. So we don't want to leak anything here, especially if we are keeping a reference to our subscriber. When the app is killed by the system, it's on the background, it's killed by the system, we can unsubscribe from our observables. And so this is the cool thing, and we should keep that in mind, especially if you're an Android developer. So what else? We have schedulers. Because I was always talking about multi-threading and how we parallelize jobs. So a scheduler is like the easiest way to introduce multi-threading in your applications. You don't have to deal with thread synchronization, none of that. I mean, here we have these schedulers, these built-in schedulers, and with just one line of code, we can say, all right, execute this job in this thread and listen to this job, to these results in another thread. And we are going to see an example for that. We have certain schedulers like that comes with RxJava. So the first one is like schedulers. It's an I/O schedulers. It's good for performing input-output operations. We have another one for computation, for doing like extensively hard computation things. We can, of course, if we need some more control over our threads, we can use our schedulers from and create our own schedulers. In our case, at SoundCloud, we have our own pool of threads, so we can control the amount of threads that Android, our app, manages or handles. And so we are using our own schedulers. But I don't think it's, unless you have like some complex logic about multi-threading, I don't think that's very necessary. Operators. So this is the coolest thing about RxJava. And we can do anything with our stream of data with operators. And I'm going to mention a few of them now. keep in mind that you can write your custom operators, and I've seen this before, and it's probably a big mistake, because you have to keep the contract. It's not that easy, it's not that friendly, although the documentation is really good. But I don't think you need any extra logic when it comes to operators. I think you can use the ones that comes with the library. By the way, the library was created by Netflix, and they are using it at a backend side. So there's a lot of cool things also on their blog, and the way they are using it. It's not from Android perspective. So here is one of the coolest operators. So you can map. I think everyone who is familiar with functional programming, might find this very well known. So basically, this is our stream of data. This is our observable emitting a bunch of items. So we can apply the function here, and we get a transformation here. That's as simple as that. Then we have flat map. These are called marble diagrams, and if you're going to dive deeper into RxJava, you will see tons of these on the documentation. So the documentation, again, is really cool. It's one of the best documentations I've seen on an open source project. So basically, it's doing the same thing. We have our stream of data, our observable emitting items, and it's going to apply the function. But the difference between mat and flat map is that the result is going to be flattened into another observable. So thus, we can continue composing and transforming data between our original observable and our client. So in the middle, if we're doing flat maps with different functions applied, we can have like a complete different result, and the client is not going to know anything about what happened in the middle. So what else? This is the same as flat map. As you can see, there's a tiny difference, and I made this mistake in the past. So if you want to keep order, the order of the emitted items, just use a flat map, not a concat map, not a flat map. I actually wrote an article about what's the difference between flat map and concat map, and especially I dive into the internals of how each of these operators work. So yeah, this is a blog post. I definitely, if you're interested in that, just go for it. I'm gonna share this presentation afterwards. So yeah, basically here I'm just showing what happens with the result. And what else? We can filter out data. So we can apply like a predicate to each of our emitted items, and we just say, all right, send this or don't send it to our subscriber. So it's pretty straightforward. We can take a certain amount of items from an observable, and this is actually a cool operator. So I found like two main use cases for this one, and it's like whenever an observable emits an item, you can do something else, like which doesn't have any side effect on the stream of data. So for example, every time I receive, I don't know, a new user, let's put an example like we are hitting an API and receiving a bunch of users. And every time I receive a new user on my subscriber, I can apply this operator on my observable pipeline and say, all right, every time I receive a new user, do this and that. For example, we could cache it. We just, we will see this in code afterwards, and we can say, all right, I received this user, I'm going to cache it, or I'm going to log something. Like there's no side effect on the data flow, but it's really, really useful. So again, that's what it's about, like streaming data streams, but what happens when we have errors? So if there's an exception in our data flow, we're going to be notified on the on-error, overridden on-error method on our subscriber. So even though it's not a good practice to handle the exception within operators, RxJava provides a bunch of them to deal with error handling. Let's have a look at them. So I'm not gonna go through all of them. Just like I put them here so you can go to the documentation. I would say that, I don't know, if you, for some reason, you don't care about what's going on, you can just use on error resume next, and that will instruct your observable to say, all right, if something happens in the middle, just continue with the next item. I don't care. We can, hand over the data flow to another observable too if we want it. For example, if there is an error when retrieving a user or something from the database and we are using observables, we can say, all right, if there is an error, just use this observable, which might go to another data source or whatever. We can have retries and so forth. So just to wrap up this introduction to RxJava and its main components, some key ideas behind RxJava that you should keep in mind. Of course, observables and observer can do anything. There's a lot of stuff that can happen in the middle without affecting, the final result. It's really nice, we'll see code. It makes very easy, and readable code to maintain. Although, but I will wait a little bit. The observable and subscribers are independent of the transformation, of course. We can apply as many operators in the middle, as many transformations as we want. And yeah, but of course, all that glitters is not gold. There is like some learning curve. If you're not familiar with functional programming, it takes a little bit to get up to speed. In our case, when we have new people, it takes around like 3 months to get up to speed because of the size of our code base and the size and the way we are using RxJava in our Android code base. I put this point actually because in the beginning, the first versions of RxJava, especially for Android where we have limited resources, the way it works is about generating a lot of anonymous classes. So in all devices, that was a big problem. So we couldn't actually use RxJava, and we had to we have two, I don't know, separate modules, like one using RxJava and the other was more like imperative programming related. So, but nowadays this is better because now it's not happening anymore. They have fixed it, and nowadays devices are way more powerful too. There is another thing again, and it has to do with Java 7, unfortunately, and it is a little bit verbose, especially when we are using functions, when we need to apply some kind of function to our stream of data. So we cannot use lambdas, for example, on Android now. So there's also some third-party libraries that deal with this, like for example Retro Lambda, which is third-party library. But we decided not to use it because it was only syntactic sugar. It had some bugs. And nowadays, with all the IDEs, we have a lot of code folding options. So yeah, I think it's up to the consumer whether or not to use it. And I want to go through an example here. I don't know, do you guys know what a clean architecture approach is? Okay, cool, nice. So for all of you that don't know what it is, it's an approach by Uncle Bob Martin, which tries to create systems, independent of frameworks, decouple, and so forth. So basically, with this applied to Android, we are running away from the Android framework and using plain Java classes. Because it's usually very bad practice to rely on frameworks. So I'm gonna go through an example and try to point out the main concept we have seen so far in code here. So this is my approach of clean architecture. So in the case of Android, I have a view, of course, a screen. Then I'm going to delegate this to a presenter. It's not more than a model view presenter at UI level. Of course, my domain classes in use cases. And I'm basically to retrieving data, I'm just using a repository pattern, so which is going to abstract me from different data sources, in this case, this or cloud. The good thing here is that what I did is to make my presenters reactive. So my presenter is going to go to the domain or the use case, which in turn is going to go to the repository and get the data, right? So this is going to be a computation, this is going to be a computation or some kind of task that's going to be happening. And when all these guys are done with their jobs, these are going to pass, all the data, back to the UI level, to the presenter. And the presenter will say, all right, I'm just listening. When you have your data done, just push something on me. And of course, again, I wanted to point out the stream. So this is a stream of data, again. Let's see this in code. Here, I'm not gonna explain each line of code. I have a repo for this. It's a full example. And there's a really nice discussions if you wanna look into that. I definitely encourage you to go to GitHub, and there's many people contributing to this model. And there's a lot of interesting points raised by other developers as us. So I just want here to just look into this only. Again, as I said, my presenter is going to be reactive. So what I'm basically doing is pretty simple. I'm just saying, all right, this guy is going to extend some kind of subscriber, just that, for now. Of course, I need to implement my 3 methods for an observer. So those are onComplete, onError, and onNext, as we have seen so far. So what I'm doing when my job is done and when I got my list of users, I'm just saying, all right, now that you're complete, I just want to hide my loading view. So I started a loading spinner when I started performing my job. So I'm just saying, all right, when there is an error, I'm going to also hide my loading view. I'm going to show an error message. And I'm going to show some kind of retry view. This is no more than a model view presenter pattern. I'm just telling my view what to do, basically, from my presenter. And when I get my list of users, I'm going to just tell my view to show them in some shape or form. What else? So, again, I repeat a lot. So just keep this in mind. I think it's a good way to run away from the framework here. And again, this is the float of data, and keep that in mind. We're going to see now what's going on at the domain level. So this is a use case. This is where I tell my use case to perform some kind of task. For instance, in this case, is to get some users, a bunch of users. So I created my abstract class, a use case, and I have an abstract method which is build use case observable, and some kind of execute. So this is going to be called from the presenter. So whenever I execute my use case, I'm just telling, all right, just build the observable for that, just some kind of task you want to do. Subscribe on. I'm just telling, but that task executed should be executed in some kind of separate thread. Again, as I said, I'm just stepping out of the main UI thread on Android here. And I'm saying, but give me the result observe on this thread. And we will see the implementation of this, which is no more than the main Android UI thread, because I do want to show the result there. But I could actually say put any thread here. And of course, I'm just subscribing my use case subscriber, which is my presenter, right? So this is all the code I need, to do all this in separate threads. As you can see, it's pretty simple. And of course, this sounds good on paper. It looks good, in theory. But then when it comes to practice, you can find some, I don't know, some issues or whatever, or like you might face other problems, but you know, it is what it is. And I'm creating a subscriptions, as I said here. So when I link my use case with my presenter, I'm just creating this subscription, which I'm going to use afterwards to unsubscribe when my app is killed. So what else? So this is basically I wanted to point out, you know, what my UI thread looks like. This is for more Android developers. Sorry for this now. And but basically, I'm just saying, all right, there's something that it's like a plugin for RxJava, which brings up some Android helpers. So in this case, I'm just saying, all right, when I get to the scheduler where I'll be listened to the result of my observable, I want to listen to it in the main Android thread. Because for all of you that are not Android developers, there's not any other way to show data or to deal with views if you're not on the Android main UI thread. Yes, so this is my use case. So it extends my abstract class use case. And when I build the use case observable, which is going to perform the hard job, I'm just saying, all right, I have a user repository as a collaborator for my class. So I'm just saying, all right, give me the users. That's it. So again, we're here now. We are just telling, we said our presenter to go to my use case, which for instance goes to a repository and it's going to retrieve my user from some kind of data source, which I still don't know. Let's see what's going on at a data layer. So this is my, my repository, of course, contains a bunch of collaborators because, of course, the main purpose is to abstract, to have an abstraction and don't care about where the data is coming from, right? So basically, here I have like my API and some kind of cache. So that's a data source for me. So here, yes. So let's pay attention to this point here. This is where I'm getting the users from my data source. Another thing that this might, start a discussion, and the way I look at this is just that I have a model for each of the layers. So I have a UI layer, I have view models, then I have domain models, and I have data models. So I'm just transforming every time I pass data from one layer to the other. There's people that are not big defenders of this, but for me, the fact that you're decoupled, it's a good thing because it favors testability and so forth. But then there's people who feel kind of annoyed every time that you have to pass some data through all the layers. You have to transform them in the middle. So anyway, we can talk about that through a beer. So here, basically, that's what I mentioned before, that I'm applying this operator, do on next. When I'm getting my users, I'm just saying, all right, REST API, get the user's entity by ID. I'm just passing in the user ID. But when you're done, when I receive the users, I just want to save them to cache. Just that, as simple as that. What else here? Yes. Oh, this is my repository. The other one was a certain specific data source for the API. So this is the main user repository class. I should have put this before the other one. But anyway, when I'm just asking my repository for the users, I just have my user data store. I created through a factory. And then this is where the transformation occurs. Like you remember I told you that when I get some kind of data from my data source, I need to pass that back to the domain layer, right? So what I'm doing here is basically mapping that data that I receive from the data source into some kind of user list entity mapper, which is going to transform my model from the data layer to a model to the domain layer. And I'm going to do the same when I'm done in the domain layer to the UI layer. Oh gosh. So that's it here. What's the interesting thing here? Here's how we create an observable. This is the observable that's going to perform the job, and it's going to go to the API, hit it, and get the users. As we can see here, what I'm doing, I created an observable. We have a helper method that is create. And when we create an observable, we receive as a parameter the subscriber. So there's a bunch of upsides and downsides using this create method. RxJava provides another bunch of methods for creating observables. But again, if you want more control over your observable creations, you should go for this approach. But one thing to keep in mind is to not break the observable contract, which means that an observable should always, when it has to meet an item, should call on next on the subscriber. When it completes, should execute complete on the subscriber. And if there's an error, it should execute on error. So this might be, it's something that to keep in mind, that we need to keep in mind, because if we forget this method, if we forget to call on complete, then that observable is not gonna complete, never completes. And so what might happen if we are if this is a unit of work and we are using it for some transformation in my observable pipeline, then it's gonna be stuck there. And one of the downsides of RxJava in general is a little bit hard to debug. So there's third-party libraries. In my case, I created one for Android that through annotations, you can use an annotations to an observable, and you can see on the Android console what's going on, what are the items being emitted in which thread. It's called Frodo. It's from Lord of the Rings, so I'm a huge fan of that. So yeah, you're bad at naming things. But yeah, anyway, what else? So, to wrap up, because this looks good or bad, maybe, I don't know. I definitely want your input afterwards. But what happens if we have a current solution and we want to start with RxJava? So I would definitely suggest the same way we did, which is start with your data level, because you can turn your SQL queries into observables in a very easy way. And at this point, you might not need any synchronization because you're already executing or performing that in a separate thread, hopefully. So, and if you're doing API calls, it's pretty easy to wrap an HTTP connection in observable. RxJava provides very useful methods for that. So, if you're at a view level, this is something we haven't, this is Android specific, so I'm not going to spend much time on it. So basically, on Android, you can convert your listeners, for example, your on-click listeners, rather than creating an anonymous class or whatever, or extending some kind of listeners, you can convert them into observables. So you have a subscriber, and then when the click happens, you will receive on next event. For us, it was a little bit messy. And actually, this is not Java code. This is C# code. It was hard to put here. Sorry, Microsoft again. So the thing is, if you're using Android, I guess it's up to you. There is something called Rx bindings, and this is a library created by Square or Jake Worthon. That makes things a little bit simpler. So, but if you're at your domain level, you have to be careful here, because this is when you might jump to another thread, or maybe it's when, I don't know, you will decide in which thread you're going to execute or perform your job. So be careful with that. And some tips and tricks to summarize here is that, yeah, we have been talking about RxJava, and by default it's synchronous. So, so be careful with that. Always specify schedulers if you want to step out of certain thread, or if you want to perform any job outside or in a new thread, just apply the schedulers. When unsubscribe is executed for every single subscriber. So every time if you create an observable the way I did here, and then you subscribe someone to that observable, that method is going to be executed for each specific subscriber. This is more, again, Android specific. Subscriptions leak memory. So always keep in mind that you must unsubscribe from your observables when your app is killed. You don't want to keep reference to screens because they contain the tree view, which, you know, it's very memory expensive. And of course, the official documentation, which is great. Some references here. I'm going to post these on Twitter. I'm going to hashtag it with Java Day here in Minsk. And yeah, I created a couple of repositories. So this is what I showed in this presentation. The other one, it's another application that I play around RxJava, and there's a bunch of samples too. So I think that's pretty much everything I have to offer for this talk. I think we have some, if you have some question, I think we still have a few minutes. And yeah, well, otherwise, spasibo. And I'll be around, of course. I mean, I've definitely loved people approaching me and, you know, having discussions. So we are kind of facing the same challenges here. So if there's any questions, otherwise, I know that you guys are hungry and you want to go for lunch